All right, pre-calc students, we are recapping for our semester 2 final. This, of course, would be our checklist. So these are the types of things I would probably want you to see on your little note card. But we're going to jump into some problems and see how some of this is working, or hopefully just refresh in your mind how some of this works. Okay? So, big thing here, the first part of chapter 6, there was quite a bit of unit circle work. All right, so we need to understand the unit circle. We need to know all those places because we need to be able to evaluate at all of those different angle measures. All right, so the first one I hope is nice and easy. Tan of pi, well, that's right to the left. Now we need to remember tan is y over x, right? So what does that mean? That means, well, my y value over here would be a 0. My x value is -1. 0 over -1 is just 0. So the tangent of pi should be 0. We could keep going. Now we have sine 3 pi over 2. Well, 3 pi over 2 is straight down. We know that the coordinates going straight down are 0, -1, and we just need to remember that sine is always the y value. It goes with the y. So here we're at -1. All right. When we take a look at this next one, 11 pi over 6, well, that's actually all the way over here. Down in quadrant 4, it's a pi over 6 angle, okay? So the idea here is that we need to remember, and if you need to write it out, that's fine, but we want to understand that because we are using cosine, we want the x-coordinate, and here, because we're going farther away from the y-axis, all right, pi over 6s are going farther away from the y. They're closer to the x-axis. That means that we're at root 3 over 2 and -1/2. So my answer here is root 3 over 2. All right, similarly on this next one, there's a couple of things to think about. First thing, we want secant. Well, that means we need 1 over x, right? Secant and cosine are reciprocals of each other. So that means we're looking for 1 over x. Now, if we have a negative angle, that means we have to go in the negative direction, or clockwise, okay? So pi over 3, but in the negative direction, should be down here, which is different than this one, right? This one is closer to the y-axis and farther from the x-axis. So our x and our y, they kind of flip-flop. Now we are at 1/2 comma negative root 3 over 2. So the last thing we need to remember is if our x is 1/2 and we want the secant, which is 1 over x, well, we just take the reciprocal for a value of 2. All right. Sine 17 pi, okay. We kind of need to just do some thinking here, right? We know that if we're at 0 here, pi, 2 pi, 3 pi, 4 pi, it turns out that all of the odd coefficients of pi are going to be straight to the left. Okay, and then if we want sine, which is our y value, well, we know that the sine, or the y value, when we go straight to the left is just 0. And our last trig function to evaluate, at least on this page to practice, -7 pi over 6. Okay, so remember, 7 over 6 is a little bit more than 1. So I know that I'm going to go a full pi and then just one little bit more, one a little higher, okay? So I know that if I need to go -7 pi over 6, I'm going a full pi and then an extra pi over 6. And of course, because it was negative, I had to go in the clockwise direction. So now I know where my angle, or where my terminal ray lies. Cotangent, you can either think of as 1 over tangent, or I just think of it as x over y. Okay? So if I can get my x-coordinate and I can get my y-coordinate, then I should be good to go. If we think about this one, x should be at negative root 3 over 2. Our y is 1/2. And so now I'm going to kind of just write those in. Negative root 3 over 2 all over 1/2. Hopefully we remember 2's can kind of cancel, and this is just negative root 3. Okay? Okay, so this is definitely something that you're going to need to remember, okay, your unit circle. Another thing that you're going to need to remember is how to convert to radians, okay? When you are given a degree, well, let's think about it. Unit conversion wise, if I don't want degrees, right, I'm converting from degrees, well, that means I'm going to need to multiply, and there has to be degrees on the bottom, okay? And we know that there are pi radians in 180 degrees. So again, the idea here is to remember if it's pi over 180 or 180 over pi, think about what you're trying to cancel. All right, this case I have degrees. I want to cancel degrees, so that's why the 180 goes in the denominator. So long story short, we can multiply this by, let's see, pi over 180. Oop, I don't need that. You know what? Let's do that again. Guys, I'm going to do this without the pi. Sorry about that. So if I do 135 over 180, I get 3/4. So now I know that I have 3 pi over 4 radians. All right, sorry about that. Okay, here's another something that you will be asked to do. If we want to convert to degrees, minutes, seconds, okay, notice I give you a decimal degree. Well, we can convert this to degrees, minutes, and seconds with a nice, easy option on your calculator. All right. Where am I? Okay, sorry about that. Okay, so 112.905. You put in the degrees, and then remember there's this angle menu. And if we go down to DMS, we get 112.54 minutes and 18 seconds. All right, so there's that. If anyone has any questions, we can go over another question similar to this in class, just because we also want you to be able to go the other way as well. All right. All right. If we continue on to number 9, I have the tangent of theta is 2, and I know that the cosine has to be less than 0. And it just says to state the quadrant the angle is in. All right. So here's my thought process on this, on something like this. It's process of elimination, right? I take my information and I cross off what I know doesn't work. So my first thing, if tangent of theta is 2, that means tangent is greater than 0, or it's positive. All right, there are only 2 places where tangent is positive. It is in quadrant 1 and quadrant 3. And why is that? Well, because tangent is sine over cosine. And when you do a positive over a positive, you get a positive. When you do a negative over a negative, you get a positive. So you are good in quadrants 1 and 3, which means I can immediately get rid of 2 and 4. I know those cannot be options. Well, I also know that cosine must be less than 0. Cosine goes with the x-coordinate, and which one's negative? Or which one's less than 0? Quadrant 3. Quadrant 1 is no good because cosine is not less than 0 in quadrant 1. Our answer is quadrant 3. Alright, hopefully that makes sense. I don't think that's too bad. But we will now do something kind of similar to that, but a little more difficult, okay? Alright, so now we actually need to kind of sketch in a triangle. Whereas on the other one, we were just trying to figure out which quadrant it is in. Now we need to find out the information about this angle with a terminal point at -3,6, okay? So, I can make a little sketch here. The point -3,6 is on the terminal side, okay? So, -3,6, I'm going to say something like that. And I'm going to make a right triangle. Now, we already know the x side, and we know the y side. All right. in order to find the secant, cotangent, sine, cosine, anything, we need to have the third side, okay? The only one that we could really do right now, actually, I mean, I guess not the only one. We could do cotangent, because cotangent is just x over y. So we do have enough to get the cotangent. However, we don't have enough to do secant, so let's take care of that one first. And to do that, we need to remember that we have a right triangle. Alright, so I'm going to call this side r. And I'm going to say that r squared has to equal negative 3 squared plus 6 squared. Alright, that's just the Pythagorean theorem. So now we say that 9 plus 36. Alright, r squared has to be 45. Or when we square root both sides, well, this is a 9 and a 5, so I'm going to actually say that r is 3 root 5. Okay. Why is it 3? Well, because I can break square root 45 down into square root 9 times square root 5, and we know square root 9 is 3. Okay, so now I actually have my hypotenuse, the side I need, and now we're ready to go. Alright? So secant. Usually we would say that secant it's 1 over cosine, right? So I know if cosine is adjacent over hypotenuse, right? Adjacent over hypotenuse, well then secant is going to be hypotenuse over adjacent. There's lots of ways to think about this. I tend to use, especially when we draw these, I tend to use letters like x, y, and r. So instead of using like hypotenuse and adjacent, I would probably say r over x in this case. And so when I go ahead and I plug in 3 square root 5 over negative 3, well, this is just negative square root 5. Okay? Now for cotangent, we said we really could already do it. We knew that cotangent is x over y, right? X over y. Well, when we do x over y, negative 3 over 6, we just get negative 1/2. That one we could have done from the very get-go. Alright? I just realized I was a little off the page. Sorry, guys. I hope you were able to understand my work. Okay, a couple more problems. 11. This is one of those unit conversion problems that I thought you guys did really well on at the beginning of the year. So these are not going to be hard for you to pick back up. You just got to practice. We need to remember that we have, well, obviously we have a wheel. We have the radius of the wheel, and we know that it's rotating at 75 RPM. But we want an mph. Alright? So if you remember correctly, unit conversions, we know we have revs per min, but we don't want revs per min, we want miles per hour. Okay, so we have to get from revs per min to miles per hour. So we start. We have 75 revs in 1 minute. I always start with the easiest conversion, the one that I know right off the bat, and I know that there are 60 minutes in 1 hour. And hopefully you remember the strategy here, guys, right? Like, now that I am out of minutes, right, they cancel, well, now I know that I have the correct time unit, right? Hours. So this is good. We know that our denominator is now in the right spot. Problem. We have revolutions, and we need miles, okay? So that's going to be a little bit tough. So, what we would probably need to do here is convert revolutions into a circumference. And what we can do is we can say that if we have 18 inches is the radius, well then I can say in 1 revolution there are 2 pi times that radius inches. Alright, and that's just circumference, right? 2 pi r. Again, why? Well, now we can cancel out revs. We got to keep going though. Alright, we know that there are 12 inches in 1 foot. We also know that there are 5,280 feet in 1 mile. And this is what we want, guys. We want inches and feet canceled, right? We needed miles. We needed hours. So now it's just a straight calculator problem, all right? So alpha y equals 75 times 60 times 2 pi times 18, and then that's all over 12 times 5,280. And I'm getting 8.03 mph. All right? So this was actually a pretty juicy problem. This was one of our tougher ones. But remember, I mean, there's ones with like cutting teeth of like a circular saw. Any of these, remember, it's really going from revs to min or from miles per hour into revs per min. All right, so really figuring out how to work with the revolutions is good. All right, now for this last one, we need to clean this up a little bit. When we were making this document, I think we goofed up the picture. Okay, so what I'm going to do, guys, is I'm gonna cancel out this right here. This, and I'm going to say C is right there. All right. Okay. Yeah. So remember, if we want the measure of AB, that really means that we want the arc length. Okay, I want the arc length of A to B right here. Now, if you remember correctly, this is actually really similar to sectors, which we just kind of did. We need to remember that arc length is a fraction of the circumference. I don't think I spelled that right. Circumference. Maybe. Okay. Fraction of the circumference. So that means, guys, well, I need to find the angle over 360. All right. I know that the full circle is 360 degrees, but I'm not going the full circle. I'm only going from A to B. All right. So the idea here is that if I made if AC is a diameter, which we had to change in this picture, right? We got rid of this. Well, then I know that from A to C is 180 degrees. And if from B to C is 87, well, then all I'm doing is 180 minus 87 to get the angle that I need. All right. So now I know that I have 93 over 360. That is my fraction of the circle. And I'm multiplying that by 2 pi r. All right? Why? Because if the full circumference is 2 pi r, but I only want this 93 out of 360, this fraction, well, then I have to multiply those two together. I have to take 93 out of 360 of 2 pi r. So I'm going to replace r with 4, and I'm going to go right to the calculator. 93 over 360 times 2 pi times 4. And I get 6.49, and we were in meters. And please remember, this is not an area, this is still just a distance, so it is not square units. All right? So this was a good little warm-up or refresher on some of our topics from the first part of Chapter 6. Later.